Okay, dear students, welcome to ninth lecture of HVAC. We'll be talking about cooling towers in this lecture. I'll draw the cooling towers. After drawing the cooling towers, I'll show the details of the cooling towers. Cooling towers, these are used in condensers. Now, what are different types of cooling towers we are generally using? That I'll be showing you. Our topic here is today cooling tower. Cooling tower is divided into two types. One is natural draft. Another cooling tower here is artificial draft. Artificial draft. Again, the artificial draft cooling tower is divided into two parts. One is forced draft, another is induced draft. These are different general divisions of cooling tower. Now, in case of cooling tower, the function of cooling tower, which is first to be explained. To explain the cooling tower, I will draw a very general cycle, which you are very aware of. This is vapor compression cycle. This is compressor, this is evaporator, this is condenser, this is expansion valve. So this is VC, vapor compression cycle, which you know very well, vapor compression cycle. Now I am trying to show you why cooling tower is used, so that there is no confusion regarding that. If you see this diagram is itself indicative. There is evaporator, there is compressor, there is condenser, there is expansion valve. That is vapor compression cycle. That is the basic refrigeration cycle you are aware of. Now what happens? In the evaporator, the heat is absorbed. After heat is absorbed, the gas gets turned into vapor. This vapor comes to compressor, gets compressed in the compressor, and after getting compressed in the compressor comes to condenser. In the condenser, it comes in the condenser and the vapor gets converted into liquid by external cooling. That liquid vapor from there comes to expansion valve, gets converted to some extent to vapor and some extent to liquid, comes to evaporator, again sucks the heat from outside and the cycle continues. Now, in condenser, we are cooling this vapor to, this was in cooling, it was the vapor state here, the refrigerant gas, it becomes liquid state here. That means, from converting from vapor state to liquid state, you need a cooling of the gas. How do you do the cooling of the gas? cooling of the gas is done with the help of a cooling tower. This is cooling tower, which is doing the cooling of the gas. In this case, the cold water from cooling tower comes to condenser. This is external cold water, remember. This is a gas going inside. This is external cold water is coming from the cooling tower. Comes to condenser, cools the hot gas because it is at low temperature. Then it absorbs the heat from the gas and itself gets heated. The water itself gets heated. This hot water is circulated back to the cooling tower, cooled in the cooling tower, and then it comes back again. And the cycle continues. This is how the cooling tower works in a vapor compression cycle. This is the basic functioning of cooling tower. That means the cooling tower is to be a device where the water is cooled regularly without much cost, because this is an accessory cost. This is not connected. Already in refrigeration cycle you have tremendous cost due to compressor running. The compressor absorbs maximum power, because of which your air conditioning or refrigeration bill is high in the building. Especially air conditioning. When you run the air conditioner in the building, the compression, because of the compression, the maximum power generated gives a high power bill of our air conditioner during the summer season. This coming season, what is coming in May, June, you will experience this. This happens due to this compressor work. So other than that, in case of your house condenser, you are making the cooling through the air cooling. That is why you are putting a fan here and passing air to the condenser, and cooling is done through air cooling. Because these are small units. In case of small units, you don't need a cooling tower. Simple air is passed over the condenser, and the air sucks heat from the gas, itself gets heated, and the refrigerant vapor gets converted into liquid. That is why when you stand behind a air conditioner in your house, there is a hot air coming outside. If you stand behind the window air conditioner in your house, and it is a running condition, you will experience the flow of hot air from inside to outside at the back side of the machine. Similarly, in case of split air conditioner, in front of the outdoor of the machine, you will get the hot air coming out. So there is evaporation happening, compressor happening, there cooling happening in the condenser and coming back to the expansion valve and going back to evaporator. Now in the condenser, we are cooling this with the help of cooling tower. Now cooling tower is a device used to cool the liquid. Liquid is water generally. This cooling tower application you might have found it is used also in power plants to produce condensate. This condensate is sent back to boiler as the boiler feed water. But here the operation is different. Here we are using, in case of condenser, the cooling tower. It is used in big buildings, in big central chilled water air conditioning systems. Cooling towers you have seen. If you have gone to a big building of Nehru Place or somewhere else, if you keep your eyes open, you will see certain structure is there at outside of the building, at the ground level, and water is falling from the top. Water is continuously falling from the top. झरना की तरह पानी बहते रहता है ऊपर से, and you can see the water is falling and the air is passing through the water, and you can see the place is moist and high humidity condition. Cooling towers you must have seen, but you have not taken notice of that. Now I am telling you to take notice of that. One example you can see in IIT library. If you go to IIT Delhi library, outside IIT Delhi library, they have kept a properly maintained cooling tower, which is actually used for library air conditioning purpose. That's a very good example of cooling tower. Other than you get cooling tower, lots of cooling towers in Nehru Place and other industrial complexes where buildings are centrally air conditioned. Now we'll talk about different types of cooling towers. Now I talk about different types of cooling towers. One is natural draft, then there is an artificial draft. Natural draft, the name implies it's natural. There is no artificial handling of the air or water here. So it's a natural draft cooling tower. In case of artificial draft, we are artificially handling air or water system. Artificial draft is again of two types. One is forced draft, one is induced draft. Now we will draw all these types of cooling towers. Now this is the total diagram of cooling towers. The diagram is very clear. I have shown you a sectional view of the cooling tower. If you go through different books, you won't get a sectional view like I have cut it. You will get the outside diagram of the cooling tower, which won't be clear to you how the cooling tower actually operates. So I have taken a section of the cooling tower to show a single line diagram how the cooling tower operates. First is natural draft. Natural draft cooling tower means it works with the help of natural air. It works with the help of natural air. So there is no outside blower in that. When the air passes through, it passes through the system, and inside that water is coming in, and it is sprinkled through small nozzles. Water is sprinkled through small nozzles. Here are nozzles which are dividing water into small atomic particles. Through these atomic particles, through these small nozzles, the water falls continuously and gets collected here. And the air comes in and air goes out. And as the air comes in and air goes out, it takes away heat from water. There's the latent heat of water is being taken out by air, and the water gets converted from hot water to cold water. This hot water is coming from the condenser. After going to condenser, remember what I said about condenser? After going to condenser, it picks up heat from the refrigerant fluid. The water itself gets heated. This hot water is passed into the cooling tower, is cooled in the cooling tower, it's sent back. That means hot water is coming in and cold water is going out. I can also write, this is hot water in and this is cold water out. I am putting the hot water here in the form of small atomic sized particles. Here are the nozzles. In this case also there are motors which rotates and sprinkles the water. You have seen the sprinkler in case of your gardens. In that case there are sprinklers, sprinkle water through the whole surface of the garden to water different plants. Similarly, there are sprinklers here which rotate in the same way and sprinkles water through the surface. Now what happens? Actually, why we are dividing water into small atomized particles? Because it follows the formula Q is equal to U A delta T. Q is directly proportional to A. The more the area increases, more the heat transfer increases. Taking this into consideration, I have divided this water particle into small surface areas, infinite number of smaller surface areas because of the atomized particles. When the air comes in contact with that, water gets cooled and cold water is being circulated again to the condenser. In this case, the only difference in case of only difficulty in natural draft is that there should be a continuous airflow, which should be natural. But in places like Delhi, where we are staying, the airflow is not continuous. In summer, you won't get proper airflow in many of the days. It is very hot and there is no airflow. So putting a natural draft won't produce the desired result. That means water won't be cooled properly. That is why natural draft tower, if it is preferred in case of seashore or such seashore plants. Natural draft cooling tower. It's provided in the seashore plants. But artificial draft cooling tower, in this case, we are using external blowers or fans. Now, whenever you use external blowers, there is power consumption. There is too much of power consumption. एक power consumption तो इसके कारण भी हो रहा है कि there is a pump, condenser water pump, which continuously circulates water to between the condenser and the cooling tower. So there is loss of power in that. Electric bill is there for that pump. Cost of pump installation is there. In this case, you are putting a outside blower, so that adds to the cost, electricity cost to the blower. Blower is a big blower here. In case of forced draft, the blower is placed on the other side of the cooling tower. And these sides of the cooling towers are generally having small apertures. There are many apertures in these sides of the cooling towers. There are many apertures. Through these apertures, air flows in. And water is flowing this way. So this follows a cross flow heat exchanger principle. Cross flow heat exchanger principle. In the cross flow heat exchanger principle, what happens? Air flows like that, water flows at 90 degrees. In case of cross flow, the air flows like that and water flows at 90 degrees, giving it the cross flow phenomenon of water. As a result of this cross flow, there is sufficient heat transfer because this water is sprinkled in atomized particles, That's in the first case. Same way, I said in the garden, you see in garden how the sprinkler sprinkles water into small atomized particles and then sprinkles throughout the garden. Similarly, here are the sprinklers and it sprinkles water through the whole system and it falls like that. As it sprinkles water, the surface area of water increases. As the surface area of water increases, the heat transfer increases, the water gets more cooled because the latent heat is taken away by air. Air which is comparatively cold air because the atmosphere comes in and takes the latent heat. Water gets cooled, cold water comes here and then cold water goes out. Through this path, I'm sorry, this has fallen, so I'll show you with the help of my pen. Here, through this path, cold water is continuously going out. Here, cold water is continuously going out. Hot water is coming in, getting cold, and cold water is going in. Hot water coming in, getting cold, and getting the cold water out. So there is a continuous flow. As you can see in this case, there is continuous flow of cold water to the condenser. And in the similar way here, the only difference is that it follows the counterflow heat exchanger principle. In the counterflow, what happens? This is the airflow. You see the drawing for yourself for some time. I'll be telling about that. You've seen the drawing? Now, I tell about the drawing. In this drawing, there is water in. This is the water in. This is the way water is falling out. This hot water coming in and sprinkled here. Here air is coming and then there is a blower here. Through this blower the air is going up. So what is happening? When air is going up through the water, it picks up heat from the water and water gets cooled. Here it works on counterflow heat exchanger principle. The water flow direction is this, air flow direction is this. So because of the counterflow heat exchanger principle, there is exchange of heat. And the water gets cooled here. And this cold water is run out and sent to the condenser. So as you can see in this diagram of cooling tower, clear from the cooling tower diagram, you can see there are three different types of cooling towers we are using. Now in case of second type of cooling tower, if you can place it, generally cooling tower is placed on the rooftop or generally placed at the ground floor level. If you place at the rooftop, the cooling towers you place at the rooftop, then there should be sufficient horizontal place through which air can pass out. Air in, air out. So there should be sufficient distance of any obstacle. Means clear space should be there to a large extent in the cooling tower. in case of this type of forced draft cooling tower. This is a disadvantage of cooling tower, this type of cooling tower, because in case of present day urbanized atmosphere, like places like Delhi, Mumbai, etc., where the congestion is too much, you don't get a space. And because you don't get space, it's very difficult to get a side space. Especially when you place it on the rooftop, there will be water tanks, there will be many other things in the rooftop. There will be electrical panels, water tanks, and so many other things. And you don't get a clear space. And when you don't get a clear space in the rooftop, naturally the circulation of air is not proper. And if air circulation is not proper, the cooling will be less. The efficiency of the cooling tower will be affected. So this type of cooling tower is not generally preferred much. The highest preferred cooling tower is nowadays is induced draft cooling tower. What happens in induced draft cooling tower? The fan is lower at the top. So what happens? The whole side area, circumference area, does not require much space. The air should come in. The air should come in and go up. What you need? In the up, there should be free space. That you get in rooftop, that you get in ground floor also. So maximum cooling towers used nowadays are induced draft cooling towers, because of the space constraint. But where there are enough space available, cross draft cooling tower, this is forced draft cooling tower is also used, where cross flow heat exchanger principle is used, because this gives a sufficiently better cooling. Only thing is that sideways you require a much better open space through which the air can pass through. Here you don't have the open space unless you have when you don't have the open space, in that case the blower can pass the air at the top. So space is not a problem in this case. So these are different types of cooling towers used in condenser water cooling. And I have also explained the disadvantages and advantages of different cooling towers. In case of artificial draft cooling tower, whether it is forced draft or induced draft, you can use blower at any point of time. That means even if there is no outside flow of air, you can use these types of cooling towers to provide proper cooling to the water. In Delhi situation, artificial draft is a perfect solution. And depending on the space constraint, you can use a forced draft or an induced draft. But in case of Chennai situation, if the cooling tower is to be located near the seashore, then you can use the natural draft sometimes, because there is continuous airflow in the natural draft cooling tower, and in the seashore there is continuous airflow. So these define different types of cooling towers used for cooling the condenser. Now, when you use these types of different types of cooling towers, there is cost added to it. Cost of installation, cost of cooling tower is there. Blower running cost of cooling tower there in case of artificial draft cooling tower. There is a condenser water pump which continuously circulates water from the cooling tower to the condenser and condenser to cooling tower. So there is installation cost of the pump, installation cost of the cooling tower, installation and maintenance cost of the cooling tower as well. Other than that, there is another big problem. Since these cooling towers are open to the environment, you can see through this fan it is open to the environment. So lots of dust particles etc. collect in the cooling tower. These dust particles along with water go to the condenser, cause the fouling in the condenser, and the condenser is to be maintained for the fouling from time to time. The maintenance of cooling tower, this type of cooling tower, increases too much. This is water cooled system. If you use the air cooled system, as in your house you are using air cooled system of cooling the condenser, in that case you don't have such problem of fouling. But air cooled system is inefficient. Air cooled system requires more power because air cooled system drops the temperature less. The cooling tower temperature, the cold water temperature is higher as compared to water cooled. In water cooled, naturally the cooling is more. Consider the condition in Delhi in summer season, the temperature is at around 45 degrees centigrade in peak summer, outside air. What at 45 degrees centigrade air is coming, what proper cooling it will be providing to water? The cooling won't be too much. It will be much less as compared to water cooled system. This is the advantage, this is the advantage of the system. Thank you for attending my 9th lecture. I hope the cooling tower is clear. We are coming to the end of the syllabus. The last chapter will be read in the next class. Thank you.